Hi, hello everyone, this is Matheus from MiningMath, and on today's video I'm going to briefly explain how you can incorporate varying economics into a global optimization using SimSched. Whenever we're dealing with selling prices and costs, we might face some change throughout the life cycle of a mining project, whether prices are fluctuating, whether you're making a project ramp up and or production costs will get lower. How to incorporate these parameters into a single optimization and find opportunities we're not finding before by using the traditional approaches. Okay, so this is the common situation, and let's assume we got the answers from our trend analysis and market analysis for the selling prices and costs we're going to face during the forthcoming years. So let's assume we have the right answers for that, and how we can take advantage of these answers into a single optimization and find hidden opportunities we were not seeing before. So this is an example from a case study from Juan Camus, which is a PhD in value creation and also general manager from Innova Mine. And he here explains how price fluctuation might change the sequence entirely. So in the first example, we have a low-grade block, a higher-grade block, and similarly we have a low value here and higher value here. Okay, and so, but considering price 1, we have a margin for this block, considering the block value minus the overburden costs. We have a margin of 15, and here we have a margin of 10. So the mine sequence here goes from 1 to 2. Okay, but when we have a higher selling price for this commodity, we might face an entirely new project development for this simple example. Okay, so here we have a margin for the higher grade block of 48, and here we have a margin of 37. So this represents the mining sequence has changed entirely, and this is where opportunities rely on. By using a global optimization, you can start to see these sort of changes. And here we're not talking about production constraints over time. We're not talking about the presence of a discount rate as part of the optimization, which is something you won't find using the traditional approach. Okay, so using the traditional approach, your sequence for this very same problem would be always this, going from a lower cost bit to a higher cost bit. Okay, even if you have prices changing, this is not part of the optimization itself. So this is one of the key aspects SimSched can help you with, finding these opportunities in face of the complexity of reality and optimizing all together. Okay, so how we can incorporate this into our optimization using SimSched. Here I have an example. The first step is the model setup. So here I have created multiple columns for the economic values within my block model. So let's assume here I have my default selling price for copper, and here I'm assuming some differences, some price changes. Here I'm assuming copper selling prices are increasing in 5, 10, 20, and 15%. And here I'm assuming the opposite. They are decreasing 5, 10, 20, and 50%. So after saving these assumptions, here I'm considering just one processing stream. Okay, I'm also considering this change will happen just with copper, but I could apply the same train of thought to any destination, to processing streams, different processing facilities, different waste dumps, different commodities, etc., etc. Okay. So moving forward over here, as I was mentioning, I can apply this selling prices to, let's assume I have a simple case with one processing facility and one waste dump, and I have all these possibilities of selling prices, and I'm combining them with each one. But this is also extensive to how many destinations you have, okay? And even though I'm talking about selling prices over here, this is also applicable to varying costs throughout the life cycle of mining projects. So maybe you have a production ramp up, your production is going up, and your costs are going down. So this is also applicable, and I have made a video about this before. You can check out probably in the card over here. But moving forward, what we need to do when we have already defined the block format, and all we need to do is to proceed with the importation. So as you can see here, my columns, which represent the economic values, or by default assigned to all the constraints. But this is something we need to change. We need to change these by assigning each one of these columns to the field type economic value, okay, to ensure they will be recognized as economic values inside SimSched, okay. So here is the scenario setup. All we need to do is to create destinations accordingly with what we have, and here on the right panel we'll have the possibility to select multiple benefit functions or economic functions for this given destination. So here I have the possibility to run using my default copper price. Copper price is increasing and going down, etc., etc. Okay. Moving forward, here is the tab of destinations, where I can add multiple destinations over here, and here is the time to add more complexity. So in the previous example, I was using one processing stream and one waste dump with one economic function at a time. Okay, that's possible. You can compare these scenarios in an independent manner. Okay, but here we can add also complexity by adding multiple destinations, and here I'm using, let's highlight this. Here I'm using process 1, process 2, dump, and process 1 is assigned to my default copper price. Process 2 is assigned to copper price plus 5%. Okay, these values are just an example. Okay, but in fact, all these processes represent the same processing stream. So how can I set up these, assuming they are the same processing stream, but these each one is assigned to an economic assumption, and these assumptions will change over time. So this is where we add this information at the prediction tab, where we have paired range. And for example, here let's highlight this. I have from year 1 to year 1, I have processing 1, which is, this one represents my default copper price. I have this prediction. Process 2 is not working, okay? So I set up a prediction limit of 0. But from year 2 up to the end of the life of mine, I'm going to delete this process. It's not going to work. And at the same time, I will work with process 2, which represents copper price increased in 5%. So this is a way how you can add this sort of complexity into a given scenario. Okay, this is also applicable to prediction ramp-ups. In this case, you would just need or increase these prediction rates over here. But here, in fact, we are dealing with the same processing stream, the same recoveries, etc., etc. Just the economic function is changing as in the steps before. Okay, so this is how you can incorporate and add this complexity to find out more opportunities for your products, to create more sustainable value, and find opportunities you were not even able to find out. Okay. So here are the highlights. I forgot I had this. And this is our invite for you to create value for your projects. We have trials for you to test for technology, and we'll be glad to help you throughout this process of extracting value and testing SimSched for your data. Just let us know. You can request a trial on our website. I will put a link in the description below this video. And also you can contact our support for more questions about these and other matters at support@miningmath.com. That's it. Thank you very much for your attention, and see you in the next time.